Hello everyone, in this video we will be solving the short answer questions of the chapter progressions. Okay, so what is the first one? Which term of the AP is 205? So it is similar to the question we have solved in the previous video. So let us check. Let us write down what is given first. Which term, let us read the question once again. Which term of the AP, the given AP is 7, 13, 19 and so on, is 205. So given is an AP. What is the AP we have? 7, 13, 19 and so on. So A1 will be 7, A2 will be 13 and A3 will be 19 and so on. And we need to check whether 205 is the term of the AP or not. So we are considering that nth term as 205. So we need to find which term it is. So we need to find the n value, which term, like it may be a 10th term, it may be a 15th term or anything like that. So we need to find the n value. So when it is said that it is following the AP, it means the common difference is same. How do you get the? So common difference is obtained by subtracting the an minus 1, that is the next term minus the previous term. So that is a2 minus a1 will give us the common difference. A2 here we have 13 minus a1 we have 7. So 13 minus 7 is 6, that is nothing but the common difference. The common difference we got it as 6. Now let us find an is equals to a plus n minus 1 into d is the formula. So in that we are considering an as 205. So a, that is the first term, is given as 7 and plus what is the d value we got is 6 and n minus 1 will keep as it is because we don't know the n value and we are about to find it. So 205 is equals to 7 as it is plus applying the distributive property, 6 into n will give us 6n, plus into minus will give minus and 6 into 1 will again give 6. So 205 is equals to 7 minus 6 is nothing but 1 and then plus 6n. So let us transpose this one. 205 minus 1 will give us 204 and that is equals to 6n. Writing the RHS first, that is 6n is equals to 204. Upon transposing, because this 6 is multiplying, so it will divide when it moves to the RHS. 204 divided by 6 will give 6 1s are 6 3s are 18, 2 is left out, so this becomes 24, 6 4s are 24. So n is equals to 34, that is 205 is the 34th term of the AP. So you should not get the fractional value when you are finding it. If it is not a fractional value, it means it is the term of the progression. Okay. Find x so that x, x plus 2, x plus 6 are consecutive terms of a GP. So what is given? It is given that this x, x plus 2, x plus 6 is following a GP. So GP is x, x plus 2, x plus 6. From this we can identify that the first term a1 is x, the second term a2 is x plus 2 and the third term a3 is x plus 6. So what is to be found? It is asked to find us the value of x. So because the given series is a GP, so the common ratio will be same. So what is the formula for common ratio? R is equals to an upon an minus 1. That is, here we have the values a1, a2, a3. So a2 divided by a1 will be the common ratio, that which will be in turn equal to a3 divided by a2. So we will substitute the values of these a2 and a1, a3 and a2 in the above equation. So x plus 2 divided by x is equals to x plus 6 divided by x plus 2. Now let us transpose the denominators. So this x plus 2 will be transposed to LHS, then x plus 2 into x plus 2 will become x plus 2 whole square, that is equals to x into, here it is x is in the denominator, so upon transposing it will multiply with the numerator, x into x plus 6. When you have more than one term, you have to keep it in the bracket. So expanding this using the a plus b whole square formula. So a square is x square plus 2 into a into b plus b square is equals to x into x will give us x square plus 6 into x will give us 6x. So, see, when you are doing this, identify each term separately. So, x square plus 2 into 2 will give us 4x plus 2 square is again 4 is equals to x square plus 6x. When we have the same term on either side of the equation with the, it means the same variable should be there, the powers should be same, and the signs of the terms should also be same in order to get them to be cancelled. So, we can cancel such type of terms which have the same variable, same power and same sign. So, x square and x square can be cancelled. So, what is left is 4x plus 4 is equals to 6x. So, let us transpose this 4x, so 6x minus 4x. So, 4 is equals to 6 minus 4. See, when you have the same variable with the same power, these are like terms, and how do we subtract these? We just subtract the coefficient. Coefficient is the number multiplying the variable. So, 6 minus 4 will give us 2x. Then we can write 2x is equals to 4, which implies x is equals to 4 divided by 2. 2 ones and 2 twos. So, what is the final value of x that we got here is 2. The required value of x is 2. In a GP, the nth term is given as minus 1 whole to the power of n into 2019. Find the common ratio. So, we will identify what is given. Let us read the question once again. In a GP, Tn means nth term. It can be Tn or An, anything. So, this is just the name. So, Tn is given as minus 1 whole to the power of n into 2019. We need to find the common ratio. So, given is the GP wherein the nth term is given as minus 1 whole to the power of n into 2019. So, let us calculate few of the terms like T1, T2, T3, so on. So, when n is equals to 1, when n is equals to 1, it means it will give us first term T1 is equals to minus 1 whole to the power of 1 into 2019. So, minus 1 whole to the power of 1 is again minus 1. So, minus 1 into 2019 will give us minus 2019. Then T2 is equals to minus 1. We are just substituting the value of n in this nth term. So, minus 1 whole to the power of, now n is 2. So, 2 into 2019. So, when you have minus 1 whole square, that is minus 1 into minus 1, minus into minus will give us plus, 1 into 1 will give 1. So, 1 into 2000 will give us 2019. I mean 2019 will give us 2019. So, T3 let us calculate. So, minus 1 whole cube into 2019. So, minus 1 into minus 1 into minus 1. Minus 1 whole cube means minus 1 multiplied 3 times. So, minus 1, minus into minus is plus, plus into minus is minus, 1 into 1 is 1 and again 1 into 1 is 1. So, this will give us minus 1 into 2019. So, when you are multiplying with minus, it will be again minus 2019, that is minus into plus is minus, 1 into 2019 is 2019. So, what are the terms we got here? T1, T2, T3. The first is minus 2019, the second is 2019 and the third is again minus 2019 and so on. So, because this is a GP, the common ratio will be same. How do you get it? T2 upon T1, which will be, because it is common ratio, it will be equal. That will be equal to 3T upon 3T3 upon T2. So, 2019 upon minus 2019. On one side it will get cancelled, and here also we have minus 2019 divided by 2019. So, the resultant value of this is minus 1 and this is also minus 1. So, we are getting the same ratio, and what is the common ratio we got here? It is minus 1. In the 17th question, we have find the sum of first 10 terms of AP. I repeat, find the sum of first 10 terms of AP. And what is the AP? 3, 5, 15, 27, 39 and so on. Let us identify the given things. The given thing is, the first thing, that is, it is an AP, and the series is 3, 15, 27, 39 and so on. What do we need to find? We need to find the sum of first 10 terms. Okay, so we need to find S10. So what is the formula for finding the sum of n terms? The Sn is equals to n by 2 into 2a plus n minus 1 into d is the required formula. So what are the things we need for this? We need to find n. What is the value of n here? Because it is said find the sum of first 10 numbers. So n value will be here 10. N will be 10. And what is a? A is the first term. So what is the first term here? We have it as 3. So a is 3, a1 or a, both are first term. Okay, first term is 3, second term is 15 and the third term is 27. Why do we need to write these separately? Because we are going to find the value of d. How do you get the d value? A2 minus a1 will give the d value. So what is the a2? 15 minus 3, that is nothing but 12 is the d value. Now we have n value, now we have a and also we have d. So we can find S10. So S10 is equals to n by 2, means 10 by 2 into 2 into a. What is the first term? 3. So 2 into 3 plus 10 minus 1 is, n minus 1 is 10 minus 1. So 10 minus 1 will give us 9 into d value is 12. So when we are solving the brackets, first we have to solving an expression, numerical expression, first you have to solve the things which are in the bracket. So 5 we are writing as it is. So 2 into 3 will give us 6 plus 9 into 12 will give us 108. So 5 into 108 plus 6 will give us 114. So when we multiply this 5 into 114, it will give us 570. That is, the sum of first 10 terms of this AP is 570. Find the 11th term from the end of the AP. And what is the AP? 7, 11, 15, 183, so on up to 183. So let us analyze the question first. Find the 11th term, and that too from the end of the AP, and the given AP is 7, 11, 15 and so on till 183. So the given, what is the given? Given is an AP and the terms are 7, 11, 15 and so on 183. What is to be found? We need to find the 11th term from the end. When he is asking to find a term from the end, what we will do? We will rearrange the AP in such a manner that the last term will become the first and the first will become the last, like that. In reverse order we will write. So now the first term is 183 and so on, and the third from the last is 15, the second from the last is 11 and the last term is 7. So because this is an AP, the difference, common difference will be, what is the formula we have? an minus 1. So what is the anth term? 7 minus an minus 1 is last but one, that is 11. So 7 minus 11 will give us 4. How do you do that? Bigger number minus smaller number. 11 minus 7 will give us 4 and the sign of the bigger number is minus. So the resultant sign will be minus. A1 is equals to now 183 and D we have as minus 4. We need to find the nth term. What is the nth term here? 11th term. So let us write the formula for nth term. An is equals to a plus n minus 1 into D. So what is a here? We have a, again because we are finding 11th term, a11 is equals to a plus 11 minus 1 is 10D. So a value is 183 plus 10 into D value is minus 40. So 180 minus plus into minus will give us minus, 10 into 4 will give us 40. So 183 minus 40 will give us 143. So the 11th term from the end of the AP is 143. Explain the terms in the formula Sn is equals to n by 2 into 2a plus n minus 1 into D. So Sn is nothing but the sum of the n terms. N is the number of terms in that AP. Then A is the first term, whereas D represents the common difference. Suppose 3 by 2 and 1 are the first two terms of GP. Then we need to find the fourth term of the GP. So 3 by 2 and 1 are the first two terms of GP. So given is a GP and the first term is 3 by 2 and the second term is 1. We need to find the fourth term. Okay, we need to find A4. The formula for A4 the term is AN is equals to AR to the power of n minus 1. Okay, so A4 is equals to AR, 4 minus 1 is 3, AR cube. And so we know the value of A, that is the first term, and it is equals to 3 by 2 here. But do we know the value of R? No. So let us calculate. R is equals to A2 divided by A1. That is nothing but equal to 1 upon 3 by 2. The denominator, if you have a fraction in the denominator, then the denominator of the denominator will move into the numerator, and so you just write the reciprocal of this denominator. So 3 by 2 will become 2 by 3. So R value is 2 by 3. So let us calculate the fourth term, that is A4 is equals to AR cube. So A is 3 by 2 into 2 by 3 whole cube, means 2 by 3 multiplied 3 times. So 3 by 2 into 2 by 3 into 2 by 3, and we are writing it 3 times. Okay, this 3 and 3 will get cancelled, 2 and 2 will get cancelled, we will get 4 upon 9. So what is the fourth term of the GP? It is 4 upon 9. Which term of GP root 3, 3, 3 root 3 and so on is 729? So what is given? It is given that GP is root 3 comma root 3, then 3 root 3 and so on. So we need to check which term of this GP is 729. So let us take that 729 as the nth term. So we have taken AN is equals to 729. So which term of the GP means we need to find n value. So we need to find the value of n. So identifying each term, the first term is root 3, the second term is 3, and the third term is 3 root 3. So because this is a GP, so we need to find the common ratio. How do you get it? A2 upon A1, that is nothing but 3 upon root 3. So this 3 can be written as root 3 whole square, because square and square root will get cancelled and 3 will remain. So this 3 can be written as root 3 whole square divided by root 3. So root 3 and this square will get cancelled, only root 3 will be left. So what is the common ratio we got here? 3 root 3, or you can rationalize also for this. Then we have AN is equals to AR to the power of n minus 1 as the formula. So what is the nth term we have considered here? It is 729. And what is the first term? Root 3 into R value also we got it as root 3 and n minus 1. We don't know the value of n minus n, so it is n minus 1. So 729 is equals to root 3 when you have a to the power of n into m into a to the power of n. When the bases are same and they are multiplying and the powers are different, then we can just simply add the powers, that is a to the power of m plus n. So what is the power of this root 3? That is invisible 1 into root 3 power n minus 1. So we will add this 1 plus n minus 1. So minus 1 and plus 1 will get cancelled. So what will be left? 729 is equals to root 3 whole to the power of n. Let us factorize this 729. So 3 2s are 6, 1 is left. Now 3 4s are 12 and 3 3s are 9. Again we have 3 8s are 24 and 3 1s are 3. Then we have 3 2s are 6, 2 is left, 21, it will become 21. So 3 7s are 21. Then again 3 9s are 27 and 3 3s are 9 and 3 1s are 3. So this 729 can be written as 1 2 3 4 5 6, 3 to the power of 6. So this 729 can be written as 3 to the power of 6. So root 3 whole to the power of n is equals to root 3. See, this root 3 can be written as, because we have 3 can be written as root 3 whole square. Why? Because this square and square root will get cancelled, again you will get 3. So instead of writing this 3, what we are writing? We are writing it as root 3 whole square whole to the power of 6 as it is. Now we have the formula a to the power of m whole to the power of n. A to the power of m whole to the power of n means, what do we do that? We will multiply the powers, that will be equal to a to the power of m into n. So root 3 whole to the power of n we are writing as it is, that is equals to root 3, 2 into 6 will give us 12. When the bases are same on either side of the equation and not equal, and they are not equal to 1, and then the powers will be equal. So the value of n here we got it as 12. In this question we have find the value of k, so that k plus 2, 4k minus 6, 3k minus 2 are the 3 consecutive terms of an AP. So what is the given thing from the question? So this is an AP. AP is k plus 2, 4k minus 6 and 3k minus 2 and so on. So the first term will be k plus 2, second term will be 4k minus 6 and the third term will be 3k minus 2. So what do we need to find? We need to find the value of k. Because this is an AP, common difference will be same. So how do you get D? A2 minus A1, that is A2 is 4k minus 6 minus A1 is k plus 2. When we have here more than one term, so we are keeping this entire thing in the bracket. So 4k minus 6 minus into plus, no sign before the number or variable means it is positive. Minus into plus will give us minus, and minus into plus again will give us minus. So 4k minus k gives 3k, and minus 6 minus 2 will give us minus 8. The common difference is same, right? Here when you subtract a3 minus a2, in that case also we will get the D value. So 3k, a3 value is 3k minus 2 minus a2 is completely 4k minus 6. More than one term is we are keeping it in the bracket. So 3k minus 2 minus into plus will give us minus 4k, minus into minus will give us plus 6. So minus k, 3k minus 4k is minus k, and minus 2 plus 6 will give us plus 4. Because these both are the common differences, these will be equal to each other. When you have this kind of thing, you need to find the common difference and we need to equate them. So what is the first common difference we got? 3k minus 8. And what is the second we got? Minus k plus 4. Because these are the common differences, so they will be throughout the series, the common difference will be equal. So 3k minus 8 will be equal to minus k plus 4. Bringing all the k's together, we get 3k minus k upon transposing, it becomes plus k, that is equals to 4 minus 8 upon transposing, it will become plus 8. So 3k plus k gives us 4k, and that is equals to 8 plus 4 is 12. 4 here it is multiplying, upon transposing it will go into the denominator. So 12 by 4 gives us 3. So the required value of k is 3. And we have how many multiples of 4 lie between 10 and 25. To find the multiples of 4 which lie between 10 and 25, what we have to do? We need to identify what is given, that is we need to find the multiples of 4 between 10 and 25. So this is a small number, so we can easily make out what are the multiples of 4. The multiples of 4 are 4, 4 to the 8, 4 to the 12, 4 to the 16, 4 to the 20, 4 6 to the 24, and 4 7 to the 28, and so on. So the multiples of 4 between 10 and 25 means that is 12, 16, 20 and 24. So how many multiples we have? Totally we have 4 multiples between 10 and 25. How many 2-digit numbers are divisible by 7? So for that, the 2-digit numbers are 10, 11, 12, 13 and so on up to 99, because 2-digit numbers start from 10 and after 99 we have 3 digits, so up to 99. The multiples of 7 are 7, 7 to the 14, 7 3 is 21 and so on. So in order to identify the last, initially you can simply make it out, but to identify the what is the last 2-digit number that is divisible by 7, what we have to do, what is the last 2-digit number actually? 99. Let us divide by 7. So 7 ones are 7, and then it will give, the remainder is 2, and then we have this 2 is brought down, so it will become 29. 7 fours are 28. Upon subtracting we will get 1. So whatever the remainder is there, that value we have to subtract from the dividend. So that is, what is the dividend we have here? 99. 99 minus 1 will give us a perfect multiple of 7. So let us check. 7 ones are 7. So upon subtracting we will get 2. This will come down for helping, 28. 7 fours are 28. Okay. So what is the last multiple of 7? It is 98. So what is the first term? 7. Second term is 14, and nth term is 98. So an is equals to, we need to find what is the last, how many terms are there. So we know that nth term or the last term is 98. So an is equals to a plus n minus 1 into d is the formula. So we know the nth term, that is 98. So 98 is equals to, first term is 7 plus n minus 1 into d. How much is the d? 14 minus 7 will give us the d, that is 7. So 98 is equals to 7 plus n into 7 is 7n, minus into plus is minus, 1 into 7 is 7, plus 7 and minus 7 will get cancelled. So 7 is n is equals to 98. Upon transposing it will become 98 by 7. 7 ones are 7, 2 is left, so it will be 7 fours are 28. So there will be totally 14 terms which are 2-digit numbers which are exactly divisible by 7. Find a and b such that minus 18, a, b, minus 3 are in arithmetic progression. So what is given? The given is the arithmetic progression. The series is 18, a, b, minus 3 and so on. So we need to find the value of a and b. So let us identify the terms. The first term is 18, second term is a2 is a, and the third term a3 is b, and the fourth term a4 is minus 3. So because it is in AP, the common difference will be same, that is dt common difference is equals to, how can we get? By subtracting a2 and a1 from a2, that is a2 minus a1 gives us d, a3 minus a2 also gives us d, and a4 minus a3 also gives us d, which will be in turn equal to each other. So let us substitute the values. So a2 minus a1 is a minus 18, then a3 minus a2 is nothing but b minus a, and a4 minus a3 is nothing but minus 3 minus b. Because these are all equal to each other as they represent the common difference, we can equate each of them. Like if you see here, we are equating here a minus 18 to b minus a, these two. First we are equating these two. Then in the second case we are equating this minus 3 minus b to again b minus a, right. So a minus 18 is equals to b minus a. Upon solving we will transpose this a to the left side, so we get 2a is equals to b plus 18, and upon transposing this 18 we will get b is equals to 2a is already there, plus 18 will become minus 18. Now minus 3 minus b is equals to minus b, b minus a we have. So what we are doing? We are transposing this b to RHS. So it will give minus 3 is equals to 2b, b plus b. This is minus b, upon transposing it will become plus b. b plus b will give us 2b minus a. So 2b minus a value is minus 3. So we have the value of b here. Let us substitute that here. So 2b means b value we got from here as 2a minus 18. So 2b is 2a minus 18 minus a, in this we are substituting, minus a is equals to minus 3. So applying distributive property, 2 into 2a is 4a, plus into minus is minus, 2 into 18 is 36, and here we have minus a, that is equals to minus 3. So 4a minus a will give us 3a, that is equals to minus 3 minus 36 upon transposing it will become plus 36. So, A is equals to 36 minus 3 is 33 and the 3 here it was multiplying. So, after transposing it will go into the denominator. So, 3 ones and 3 11s are 33. So, the value of A we got here is 11. And now we can get the value of B by substituting this in this. Let us mark it as equation 1 in equation 1. So, B is equals to 2A minus 18. Here we have 2A minus 18. Let us substitute this A value in this. So, B is equals to 2, A is 11 minus 18. 22 minus 18 will give us 4. So, the required A and B values are 11 and 4. In AP, if AN is equals to 4n minus 14, find SH. So, if you understand the question, nth term is given as 4n minus 14, that is AN is equals to 4n minus 18 and the series is an AP. And what do we need to find? We need to find S8. So, what are we supposed to find? S8, sum of 8 terms we are supposed to find. Because this is an AP, we can find the, let us find few of the terms in order to find the D. Why we are finding this? Because for finding the S8, the formula over here is Sn is equals to n by 2 into 2a plus n minus 1 into D. So, neither we have n nor we have a, n we have, that is 8, okay, but we do not have a and D. So, in order to calculate that, let us take the nth term. For here it is given as An is equals to 4n minus 14. So, first term will be A1 is equals to 4 into, instead of n we are substituting here 1. So, 4 into 1 minus 14 will give us minus 10. 4 ones are 4 minus 14. One positive value, one negative value we have. It means we have to subtract. 14 minus 4 gives us 10 and the sign of the bigger number is minus. So, it is minus 10. Similarly, let us find A2. A2 is nothing but, in this again we are substituting 4n, n in this case is 2 minus 14, 4 2s are 8 minus 14, 8 is a positive number, we have to check the sign of the number before the number here, then 8 is positive and 14 is negative. So, 14 minus 8, one positive one negative value means we have to subtract. 14 minus 8 gives us 6 and the sign of the bigger number, that is 14, is minus. So, the resultant sign will also be minus. So, 8 minus 14 gives us minus 6. Because now we have A2 and A1, we can find the value of D. How? D is equals to A2 minus A1. So, minus 6 minus of minus 10. So, minus 6 minus into minus, this bracket represents into, right. So, minus into minus will give us plus 10. So, again a negative number and a positive number we have to subtract. 10 minus 6 gives us 4 and the sign of the bigger number is positive. So, resultant sign will also be positive. So, we have for A1 is nothing but the first term, right. A1 is the first term, D is given as 4. Now, we can find using the formula Sn is equals to n by 2 into 2a plus n minus 1 into D. So, what is asked to be found? That is S8 is to be found. So, S8 is equals to, now here because Sn, right. So, n is 8, 8 by 2 into 2a. What is 2? 2 into a value is the first term, that is minus 10 plus n minus 1. 8 minus 1 is 7. 7, D is 4. So, we can cancel this. We cannot cancel this 2 and this 2. Okay, outside the bracket we have, right. We can cancel 2 4s are 8 and here plus into minus gives us minus, 2 10s are 20 and then 7 2s are 14. A positive and a negative number. So, we need to subtract. 20 minus 14 is 6 and the sign of the bigger number is minus. So, plus here the value the sign of 4 is plus, nothing is there means we have positive, it is positive. So, plus bracket means into, plus into minus will give us minus, 6 4s are 24. The sum of first 8 terms is minus 24. Hope that is clear. We need to find the 25th term from the end of the AP. When something is asked to be found from the end, we need to rearrange the series. So find the 25th term from the end of the AP 3, 8, 13, so on up to 253. This is the given AP. We need to find the 25th term from the end, okay, from the end. So what we will do, we will rearrange the series. So the last term will become the first term and so on, and the first term will become the last term, like that we have to rearrange. Now A1 or first term will be 253 and this 3 is nth term, that is last term. An is equals to 3, an minus 1 will be 8, an minus 2 will be 13, like that. Now we can find the D value common difference, that is nothing but an minus 1, the last one minus the previous one. So 3 minus 8 will give us minus 5, because we got the value of D, we have the value of A. Now we can find the 25th term. So an, we have the formula, an is equals to A plus n minus 1 into D. So A25 will be A plus n minus 1, that is 25 minus 1 will give us 24D. So A25 will be, A is 253 as we have here, first term is 253 plus 24 into D is minus 5. So it will give 253 plus into minus is minus, 24 5s are 120. So it will give us 133 as the 25th term from the end of the given series. 5, 8, 11, 14 is an AP. Find the sum of first 20 terms. So the given AP is 5, 8, 11, 14 and so on, and we need to find the sum of first 20 terms, that is nothing but S20 we need to find. So identifying each term, A1 the first term will be 5, A2 the second term will be 8, A3 the third term will be 11 and so on. So we can, because it is an AP, we can find the common difference, that is A2 minus A1 will give us common difference. So 8 minus 5 is nothing but 3 is the common difference. Now sum of first 20 numbers, sum of n terms is nothing but, the formula is n by 2 into 2a plus n minus 1 into d. So how much is n? N is 20, S20 we need to find, right? So 20 by 2 into 2a, a is first term is 5 as we have here, plus n minus 1, what is n here? 20. So 20 minus 1 gives us 19, d is 3. So 10 into 2 5s are 10 plus 19 3s are 57. So 10 into 67 will give us 670 as the sum of first 20 terms of this series. Then we have which term of the GP is 3 of the GP, the GP is 3, 9, 27 and so on is 2187. So the GP is given and we need to find which term it is, means it is a term of that GP, but we need to find the nth term, means what is the value of n we need to find. So given GP is 3, 9, 27 and so on, and the nth term is 2187, we need to find the value of n. So it is a GP, so we get the common ratio. Common ratio we get by dividing the two successive terms. So A2 by A1 will give us common ratio, that is nothing but 9 upon 3. So 3 3s are 9 and the value of R we got here as 3. So we know the nth term, that is 2187. We know the first term, that is 3, and we know R and it is also 3. We need to find n, okay, which term it is. So the formula is an is equals to a into r to the power of n minus 1. So an is 2187 is equals to a is 3, r is 3 to the power of n, we don't know, so we are keeping it as it is, n minus 1. Because we have the same basis and they are multiplying to each other, the powers should be added. As we know the law, a to the power of m into a to the power of n will give us a to the power of m plus n. So 3 to the power of 1 plus n minus 1. The first power is 1 plus the second power is n minus 1. Now upon factorizing 2187, we We can write this 2187 as 1, 2, 3, 4, 5, 6, 7, 3 to the power of 7. Now, because we have one more law, a to the power of m is equals to a to the power of m. If we have like this, when a is not equal to 1, then the powers can be equated. So, here the bases are not 1. So, now and they are equal. So, we can equate the power. So, 7 is equals to n. So, which term of the GP is 2187? It is the 7th term of the GP. So, if you want the explanation of this, how we have done this factorization. So, we have taken 3 as a factor, 3 7s are 21, 3 2s are 6, 2 is left out. So, 3 9s are 27. Again 3 2s are 6, 1 is left. So, 3 4s are 12 and again 3 3s are 9. 3 8s are 24, again 3 1s are 3. Here we have 3 2s are 6, 2 is left. So, 3 7s are 21. Again we can continue with 3, 3 9s are 27, 3 3s are 9 and 3 1s are 3 until we get 1. So, how many 3s we have? 1, 2, 3, 4, 5, 6, 7. So, this 2187 can be written as 3 to the power of 7, which are not divisible by 3. In order to solve this question, we need to first understand this. So, what is given is integers between 1 and 50 are given, that is 1, 2, 3 up, so on up to 50. So, we need to find the sum of all the integers between 1 and 50 which are not divisible by 3. It means what we can do, the idea that behind solving this problem is, first of all we will find the sum of all the integers between 1 and 50, up to 50 we will find. Then from that we will subtract the integers which are the sum of integers which are multiples of 3. Okay. So, that will give us the sum of all the integers which are not divisible by 3. So, what are the multiples of 3? 6 means 3, 3 to the 6, the table you can say 3 3s are 9 and so on. Here 50 is a smaller number, so you can make out that 48 is the largest number which is divisible by 3. Instead, you may get some bigger number. So, what is the idea behind finding that number which is divisible by 3? So, just divide 50, whatever the last number is given, divide that by 3. So, what is the remainder you are getting? Here we got it as 2. 3 1s are 3. So, 2 will, upon subtracting we will get 2. Then 3 2s are 0 will come down. So, 3 6s are 18 will get. So, upon subtracting we will get 2. So, the remainder we got here is 2. So, when you subtract this remainder from the given number, then we will get a number which is exactly divisible by 3. So, 50 minus 2 is 48. Now, this 48 is divisible by 3. So, the last term will be 48. Now, we can find that, we can see that this is a AP, right. Then the A1 is 3 and A2 is 6. So, we can find the common difference, that is A2 minus A1 is equals to 3. Here we got the common difference as 3. So, we need to find how many such terms are there which are divisible by 3. So, that is AN is equals to, for A plus nth term is 48, right. So, AN is equals to A plus n minus 1 into T. So, AN is 48, A is 3 as we have here, then n minus 1 we do not know n value. So, we are keeping it as it is and D is 3. So, we got the 3 and 3 will get cancelled and n value we got it as 16. So, totally there are 16 multiples of 3 between 3 and 48. Now, moving ahead. So, what did we get? We got the first term as 3, common difference is 3 and the number of terms which are divisible by 3 are 16. So, what we are doing? We are finding the sum of all the multiples of 3, that is 16 multiples of 3. So, what is the formula we have here? It is A plus n minus 1 into D. N by 2 into 2A plus n minus 1 into D is the formula we have for sum of 16 terms. So, n is here 16, 16 by 2 into 2 into A is 3 plus n minus 1, 16 minus 1 is 15, D is 3 again. So, 2 and 2 8 is 16, so we got here 8, 2 3 is 6 plus 15 3 is 48 we got. So, 8 into 45 plus 6 will give us 51, so that will be in turn equal to 480. 8. So, the sum of the multiples of 3 is 408. Okay. Now, what do we need to find? We need to find the sum of all integers which are not divisible by 3. For that, what we will do? We will find the sum of all the integers up to 50 and then we will subtract sum of 16 integers which are divisible by 3. So, sum of 50 integers, how do you get? First 50 integers. So, n into n plus 1 by 2 is the formula we have. N into n is equals to n into n plus 1 by 2 is the formula we have. So, what is n here? We have it as 50. Then we have n plus 1 as 50 plus 1 divided by 2. So, 50 into 51 divided by 2 will give us 1275. Now, the sum of all integers which are not divisible by 3 are S50 minus, we have S50 minus S16, that is sum of all the integers up to 50 minus sum of all the multiples of 3, that is 1275 minus 408 will give us 867 is the required sum of all the integers between 1 and 50 which are not divisible by 3.